if a equals 2x square minus yz times I unit vector plus y square minus 2sz j unit vector plus s square 0 raised to power 3 k vector, and says we have to show that the divergence of curl A equals 0. So how do we find, or how do we show that the divergence of the curl of A, the curl of this is equals to 0? The first thing we have to understand is that the divergence of curl A can be written as div of curl A equals 0. So we have to show that this guy equals 0. Now let's take it step by step. Let's first find the curl of A. So the curl of A can be written as this in matrix. So we have I, J, K. Find the determinant. So we have the curl is partial S, partial Y, partial Z. And our A, for the height component, we have 2s square minus yz. So we have 2s square minus yz. For the middle component, which is J, we have, let me write it like this. It's too small. Y square minus 2sz. And for the last component, which is for K, we have s square z raised to power 3. So now we can now evaluate. Don't forget that this is plus, minus, plus. So we have plus, we have I outside. So we are going to fix the first row and the first column. So we will left with these guys. So we have partial y of s square z raised to power 3 minus partial z of y square minus 2sz. Now for the j, we are going to fix the first row and the second column. So we have minus j into partial s of this. We have partial s of s square z raised to power 3 minus partial z of 2s square minus yz. Now close it. For the kth component, we have plus k. So we are going to fix the first row and the third column. So we have partial s of y square minus 2sz minus partial y of 2s square minus yz. So now we continue with differentiating. So the first one is that we differentiate with respect to y. This guy will vanish as 0. We differentiate with respect to z. We are going to have minus 2x, so in which we have plus 2x. So the next thing is to differentiate this guy with respect to s. So we are left with minus j into, we have 2sz raised to power 3. Differentiate this guy with respect to z. We have plus y. But this will be 0 and this will be y. So we differentiate with respect to x here. We have minus 2z. Differentiate with respect to y here. We have plus z. So now we obtain 2si minus 2s z raised to power 3 plus y into j plus, this is just unit vectors. So we have minus 2z plus z, that's just minus z into k. So this is our curl of A. So the next step is to find the divergence of this curl of A. So we have div of curl A. So the divergence can be written in this form as partial s I plus partial y j plus partial z k dot the curl of A. So we have 2si minus y plus, it's just rewriting this as y plus 2z raised to power 3 j in vector minus zk. So we have that. Now we can now take the dot product of these two guys. So taking that, we have partial x of 2s plus partial y of this guy. So there's negative here, so this guy will be minus. Because of the negative sign here, we have y plus 2s raised to power 3. And this guy, we have negative outside also, we have minus partial z of z. So now we differentiate. Here we have 2 when we differentiate respect to x. When we differentiate respect to y, we have minus 1 here. Likewise, this when we differentiate respect to z, we obtain minus 1, in which we have 2 minus 2 equals 0. So therefore, div of col of A equals 0, in which we can now claim that div col A equals 0 as required. So we have div col A to be equals to 0. So that's the end of the proof. Thanks for watching.